welcome guys. So this is Chain of Thought, Scale's podcast on all things Scale AI research. This is our first episode, so we thought we'd kick things off by talking a bit about all the research that we do here at Scale AI and diving a bit more deeply into our agents and environments work. So why don't we just start off with a round of intros? Yeah, I'll go first. So my name is Brad Kenstler. I'm the head of agent capabilities and environments research here at Scale. Bing?
Yeah, my name is Bing. I run the research team here at Scale.
Hey everyone, my name is Chetan. I lead the product team for agents and environments here at Scale.
Cool. So guys, we do a lot of interesting research here at Scale that I think the audience might not be too familiar with. So maybe we could just start Bing, could you tell us a bit more about Scale's research team? We're widely known as a leader in data, but we do a lot of different kinds of research. So curious to hear a bit more about all the different kinds of research we do.
Yeah, certainly. So our mission here is to advance AI with frontier data and the eval. A few key areas of our research focus: eval, data, and alignment. Right. So eval is a significant challenge for the industry these days. Evals are falling behind of the frontier model development. So here at Scale, we put a lot of research effort in building the frontier eval that can truly measure and track the progress of frontier AI capability improvement. As an example, HLE, Humanity Last Exam, is one of the latest kind of output from the research team from Scale that has been widely adopted by frontier labs, frontier models, in measuring the capability of knowledge and reasoning. Right? So we are just trying to build yet another HLE type of eval that can challenge the frontier model capability. So that is on eval. Second major area on science of data, right? So we tackle key challenges in data production with human in the loop, data selection for large language models, as well as kind of a data quality assessment, right? So in addition to that, we also continue to innovate on methodologies for data production as well as new type of supervisions. So that is the research on science of data. And last but not least, we do research on alignment. We do post-training in text, multimodal, agentic capabilities, and we continue to innovate on method and supervisions that can continue to improve frontier model capability in a safe and a robust way. Right. So these are the few areas of focus that we do at Scale research: right? Eval, data, and alignment. Yeah.
Awesome. So yeah, it sounds like we're covering a lot of ground. Chetan, so you're our lead AI product manager from our product team here. So curious to learn a bit more from your perspective. How does product work with research?
Yeah, it's a great question. And so, when you think about what we actually do here at Scale, right? We basically build out data products, which span across the data infrastructure, the evals and training data that ultimately help our customers, which are a lot of the big labs, build out models and intelligent AI systems that are really aligned with delivering economic impact and producing product value for their own customers and downstream users.
Right.
And I think there are kind of two ways in which you can get to that end state, right? One is you can take a very academic or research-oriented approach where you read all the papers, you test your models out against different benchmarks and evals, and you work with a scale to figure out what distribution of data is going to lead to model hill climbing on those evals. The other approach is you can take, this product-led thinking where you actually go out into the market, you try to understand what kind of use cases are gaining adoption, where are models actually making an impact in the world, and what are the gaps and the limitations. And you kind of work backwards from, what the future state of intelligence looks like when you put it in the hands of users. And I think at Scale, we don't really discount one or the other. We think that the two are, intrinsically tied. And we believe that, the future of intelligence has to be co-developed by both product and research. So my team, works very closely with the research side to, answer that question of how do we, direct a lot of our research initiatives around, commercial applications and improving model capabilities that allow our customers to create more value and capture that market value and really align what they're doing with the priorities of business decision makers. And we think this doesn't just help our customers build out better products, but I think it just helps advance the overall AI ecosystem as a whole.
Right.
Yeah,
this is a great point. Yeah. So in terms of the marriage between research and the products, so agentic capability is definitely a key area that's receive a lot of attention these days. And within research, within Scale, we also have a lot of research effort around agents capability and environment. So, Brad, do you want to talk a bit about what type of research that we do here?
Yeah. So the agent capabilities and environments team, we really focus on three kinds of research. So the first is agentic evaluations. The second is environments research, and then the third is agent environments data. So going back to the first, right? Evaluating agents is a complex thing, right? And so we focus on how can we evaluate agentic capabilities as agents become more and more complex. It turns out this is a pretty non-trivial problem, right? You take any specific use case like an agent that can automate tasks that a financial analyst might do, as an example. In order to actually evaluate an agent's capability to do that, you need to create an environment for that agent to perform tasks in. You need to actually come up with really complex and difficult tasks that mirror the types of tasks that the financial analyst might do. And then you need to actually marry that with some kind of economic value, so we can better understand, right, not only how capable are these agents, but how performant are they on tasks that actually are meaningful to end users and to customers. The second thing that we focus on is environment design. So whether you're evaluating agents or you're training agents, it's incredibly important to actually create realistic environments to deploy those agents into. And it turns out there's a lot of complexity, which I know we'll go over later in terms of like how to build and design agents effectively. But that's part of what we do is we focus on, take an agent domain, a specific area, how do we create the most realistic environment for us to evaluate and train those agents within. And then the third is, building world-class data for our customers. So nowadays, RL is really the paradigm that our customers follow for training their models to be effective agents. And so we do a lot of thinking about, how do we create high quality data? How do we package it and enable our customers to really advance the capabilities of their foundation models?
Yeah. Absolutely. And, obviously, I think agents are very much front and center in the AI world right now. And, we hear that terminology being thrown around for everything across, the application layer and, even some of the products that have come out of the big research labs. Do you mind maybe just defining for the audience, like what is an agent? How do we think about, what agents actually are?
Yeah. So this is one of those questions where, like, if you ask three different people, you might get three different answers. So I'll kind of give two answers here. I think, the first, most simply, an agent is a model or a model-based application that interacts with different external systems to accomplish some sort of task. So probably like the most famous agent that everyone uses almost every day is ChatGPT, right? We tend to not think of ChatGPT as an agent, but if you look at its capabilities, it actually is. ChatGPT can, do searches on the internet. It can run code. It can produce visualizations. And so all these things are agentic capabilities. So you have right within, the most famous AI app out there, all the core pieces of an agent. You have the models, you have the application, and then you have the external systems that model interacts with. Now, if you take a step back, there are, broadly speaking, also two different categories of agents that most people talk about these days. The first is what we tend to call workflow agents. And so this is a system kind of similar to like a Zapier workflow where you have some like predefined structure of tasks and nodes that is augmented or enhanced with an LLM in the loop. So this could be something like, you have some workflow that programmatically runs an API call on like your email inbox, and then it passes those emails to an LLM. That LLM can then summarize what's in your inbox and then send you a summary report. And so you see this a lot really in the enterprise space. A lot of the SaaS players out there that have agent products, they're more centered around this type of predefined workflow agent. The second kind of agent, and this is the one that's really more relevant to the foundation labs and the customers that we work with, is an autonomous agent. And so an autonomous agent is one that's really driven by a model. So you take a very powerful foundation model and you give it a set of tools. these tools interact with external systems. It can be an API, it can be like some remote coding environment, it can even be the internet. And this agent is allowed to basically use these tools dynamically in order to complete a task. So typically users will ask the agent, hey, can you generate this research report for me on like competing products in this space? This is probably most common in applications like deep research. And then the models basically use their tools to effectively answer the question. So they make tool calls, like, running search queries on the internet. They look at the results. And then they basically decide, okay, do I need to run another search or do I have enough information? So there's this dynamic nature to them. And so it's this latter agent that, at least on the research side here at Scale, we tend to think a lot about because this is where there's a lot of opportunity to increase agent capabilities. The direction of travel, we'll talk a bit about this, is, we want autonomous agents that can handle really long horizon, complex end-to-end tasks. And that's where the biggest opportunity is for boosting agent performance.
Absolutely. And I think with a lot of these agents, they don't just kind of operate in a vacuum, right? I think everything you said about autonomous agents, they have to interact with some sort of a system around them, and I think that's what we often refer to as an environment. Do you mind like speaking to what an environment is and how we should be thinking about like the interaction between agents and environments?
Yeah, absolutely. So environment. So this is also kind of a buzzy term, but also something that's really fundamental to agents, not only in terms of how we evaluate and train them, but also just what they look like in deployment in live applications. Put simply, an environment is a system or a set of systems that an agent interacts with to accomplish its task. So just going back to ChatGPT for a second, right? What kinds of environments does ChatGPT interact with? The internet. It has a remote code execution environment, probably some service like Modal or something like this. And then now you can actually add connectors to ChatGPT that directly integrate it with things like G Suite, Box, Linear, right? So these are all examples of different systems, and the collection of systems is what we call the environment. We'll talk a bit more about this later, but environments have a special flavor that are designed for evaluations and training. And these look a little bit different than what environments look like actually in production live systems that we use every day.
Yeah, and just adding on to that, I think the way I like to think about environments is it's kind of like the world, that an agent lives in, and it has to like understand the rules of, figure out how to operate within that space in order to complete some sort of tasks. And just kind of adding on to that as well, I think the way these environments look and they present themselves will be very different depending on like the type of agent that you're either training or using in a production setting. So like for coding agents, many people here use Cursor or Cloud Code. The environment is like the repository that it is dealing with, which includes all of the files from like the test files, the Docker files, code related to the actual application, all the backend requests, and the agent might also be able to see error logs and terminal outputs in this environment. So you can kind of navigate through that and perform tasks like fixing bugs or building new features. For something maybe more like a ChatGPT agent, the environment could be an entire operating system, right? Where the agent has access to applications like a calculator or Excel, or even a browser. So it can, go to different websites and perform actions. And so a lot of these environments can be, hyper specific to the type of agent, but they could also be, very generic. And I think as, intelligence changes and the types of products that people end up building, start to diverge a little bit, I think we're going to see a lot of different types of environments that are being built for training outcomes.
And also, this is definitely a very evolving field. Where with the continued improvement of agent and model capabilities, people are also actively iterating, what type of environments can produce the best kind of the supervision signals and eval signals for the frontier models, right? So different applications, verticals, as well more generic environments, like the word model type of thing.
Exactly. Yeah. Bing, I'm curious, on the research side, what are some of the trends that you're seeing around agents?
Yeah, sure. So these days, we are definitely seeing an increasing capability of agent that can handle complex tasks, interacting with multiple systems, and over gradually long horizon of tasks, right? So in terms of the complexity of the tasks, in terms of the end-to-end nature of the task. So we are seeing a lot of exciting advancement these days from the frontier model perspective. I think a couple of factors enabled the recent advancement of agentic capabilities. Number one is about the long context modeling, right? So with the frontier models can handle millions of tokens these days, it enables the agent to interact with users and with the systems in the multi-turn setting. It can do knowledge retrieval as needed, and retrieve all the results and do the consolidations and synthesize the output. Right. So long context modeling is definitely a foundation piece to the recent advancements of agent capabilities. Another aspect. Reasoning with tool use, right? So we talk a lot about the chain of thought reasoning. Over the past 2 years, reasoning has been kind of married with tool use for different kind of search, code executions, or even more real-world tool use capabilities like different MPCB servers, right? So being able to do kind of long chain of thoughts and with planning and action taking is definitely another kind of main enablers for the recent agent capability. And last but not least is RL and the environment that we talk about, right? So for RL, if you give the algorithm a reward signal, RL can always get it there, right? So that is why people put a lot of effort these days on designing the environment and providing the right reward signal to the agent, so that the agent can continue to iterate by itself, right? So we are definitely seeing a phase where we are go beyond kind of just providing simple trajectories to the model, let the model to learn, but starting to let the model to explore by itself in the environment and continue to iterate. Yeah, I think these are the key some of the key aspects that enables the recent advancement of agent capability. Yeah. And also, curious, Chetan, so besides these agent capabilities, we are also seeing a lot of new agent applications and product uses. What are some of the exciting things that you are seeing these days?
Yeah, absolutely. I mean, there's just been an overall explosion of agents in the market. I think, it's hard to escape a lot of the noise, but I think there's been a lot of, very exciting advancements we've seen. I think to start off with, autonomous agents are becoming a lot more capable, and we're seeing them applied towards different domains. I think there is still a pretty significant gap between, the expectations we have for the kind of work that these agents can and ideally should be able to do versus, the reality of their performance. And so there's still a lot of room to improve how, reliably they can take on, meaningful chunks of human knowledge work. But we're seeing, a lot of people tackle all sorts of different applications and use cases. And I think, as you mentioned, a lot of that improvement is coming from, the research layer, the advancements in model capabilities, new frameworks and protocols for how these agents can interact with different systems. But a lot of it is also just coming from, deeper integrations of these agents into specific workflows. And so whether that's, using MCP to access data, that's stored in all sorts of, different systems and different tools that an agent might interact with for a particular domain. Or even prompt engineering, or setting up multi-agent architectures and systems for being able to reliably do work. I think people are kind of exploring all sorts of different opportunities and different ways of setting these up. And I think if you really look out there, what you'll probably notice is that a lot of developers are tackling agent problems across just about every domain. I would imagine that every niche has some sort of agent that's trying to take on knowledge work. I think some work better than others, but some of the key spaces where I think we're really seeing a lot of adoption are obviously coding. This has been one space where I think agents have delivered a lot of, business and consumer value for, quite some time now. And I think, the product market fit here is undeniable. And we're also starting to see some additional segmentation in the coding space. For example, you have, these vibe coding agents like Lovable, or, for Cell V0, you have Replit agents. And these are kind of designed for some of the more, non-technical users to create landing pages or simple websites that might not necessarily be deployed in a production environment, but are good for hobbyist use cases. Then you have more autonomous coding agents like the Devons, kind of the Claude codes, the codexes of the world, where you can, trust it to asynchronously, take on a larger chunk of a coding workflow. And then you also have the product category around these coding assistants that are baked into IDEs like Cursor and Windsurf. And each of these are capturing quite a lot of market value. I think outside of coding, we are seeing some early development of agents like ChatGPT agent that are more general purpose. They can use computers, they can use browsers, they can use OS level applications, and combine those capabilities with reasoning and the ability to interact with different APIs or MCP servers so that they can take on more long horizon tasks. I think a more autonomous version of this would be something like a Manus. And I think these are still in the nascent phase of adoption, but a lot of the training work that we do here at Scale is very much geared towards improving these. And then I think outside of those spaces, some of the other categories that I'm excited about is customer support, go-to-market, workflow agents like Sierra, Decagon. I think they're doing some very exciting work there. We're seeing agents being applied for legal use cases, where Harvey's been a big player for a long time, and even spaces like voice AI are starting to have their moment. We're seeing all sorts of voice agents kind of capture the the call center market, or building out different AI receptionists. And so there's a lot of value that's being created, and I think people are starting to finally get the balance right, between the accuracy of these models, the cost and what it takes to actually deploy them in production, and the value actually generated for businesses. So I imagine the next 6 to 12 months are going to see a lot of exciting advancements.
Exciting, yeah. I just want to add one thing.
Yeah.
So on the research side, AI research agent is something that people talk a lot these days.
Yeah.
I'm sure many of the labs are investigating in this area where we can build agents that can just do AI by itself and continue to iterate and improve itself. So there's an article about AI 2027 that paint a big picture about that. I know people have a different opinion, but apparently a very exciting area that people are looking into these days as well.
Yeah. Absolutely. Well, I think one thing I'd also just comment on is just the impact of MCP. Yeah. I mean, we're already seeing it now. I mean, with and for viewers that don't know what MCP is, in short, MCP stands for Model Context Protocol, right? It's basically a protocol that allows makes it easy to integrate agent and model applications with third-party services and APIs. And once this protocol came out and the industry kind of converged around it, all of a sudden became very easy for purpose-built agent applications like Claude Code or Cursor to integrate context from external systems. And so that's taking these specialized tools and making it easy for users to bring context from their Notion or their Linear, and then actually leverage that context in the tasks that they're doing in their code base. And so we're seeing this proliferation of integration between agent applications and all the different third-party APIs and services out there. It's actually kind of interesting because it's not so clear how the third parties are reacting yet, right? Some are very gung-ho about, hey, I want agents to be really good at using our services. And others are kind of well, I'm not so sure, because they want to be building their own agents, right? And so it's kind of interesting to see how that's evolving. But we can already see the impact today in bringing your own context into basically any agent application you're using.
Absolutely.
Yeah, I think MCP has been very exciting. And, one commonly debated topic that I feel like I've heard come up has been, do we fundamentally believe that, these general purpose agents are going to rely more on, interacting with APIs and MCP servers, or are they going to, directly use interfaces when, using different, tools and services? I'm curious if you have a thought on that.
Yeah. So, I mean, when you say interfaces, I'm thinking of graphical user interfaces.
Exactly. Yeah. Literally clicking buttons on a website versus, using the MCP server for,
so it's interesting because when GUI agents, right, first came on the scene, right, I think Claude Kua, a computer using agent, and Operator, these were very standalone agent products. They had their own fine-tuned models that were basically trained to use computers and browsers, kind of like how humans do, right? Like you click, you drag, all this kind of stuff. And they were effective at some tasks. They were definitely really exciting because it was a new interface, a new way of having vision language models interact with these systems. But what we've seen since then is like this convergence of general agents that can use both these visual interfaces and tools, right? And so I think ChatGPT agent is a good example of this, as is Manus. But I it'll be interesting to see which way the applications go. But I'm of the opinion that effective agents will be able to seamlessly use both types of interfaces to interact with systems. So for certain tasks where there aren't good text-based APIs, or you need like fine-grained visual control, I think we're going to see like the GUI agent capabilities really play a big role in automating certain tasks. Whereas, if you can solve a task using an API, then tool use and MCP will pretty much save the day. So really agents that can seamlessly alternate between two of these things. I'll give a really quick example. Yeah. So one of them is PowerPoints, right? So there are a lot of tools out there, and I think ChatGPT agent uses a text-based tool that like makes it easy to generate PowerPoint using just text, right? But as you might imagine, if you do that, you might miss out on some of the visual richness that like PowerPoints actually need. And in fact, this is one of the shortcomings of ChatGPT agent for PowerPoint today. It can make the deck, but like it can't make it really look really good. And so that is something that can be effectively handled by a GUI agent that can use its visual understanding, can use like drag, click tools to actually resize images, make slides look really good. And so I think we'll see more use cases of this where agents can seamlessly use both.
I agree with that. And I think, we're already starting to see a lot of, environments that are being used for training include, the ability for an agent to decide whether it wants to like click on a button, use the graphical interface, or, call a tool. And I think, part of that next stage of training and getting these agents to be even more intelligent and like figure out the most efficient way of navigating the website will be empowering them to like make these decisions on their own. And so I think there's a lot of exciting work there. To that point, obviously, I think, we've seen a lot of advancements on the agent side. There are also a lot of limitations and gaps, which is why the research space right now around this is so exciting. And I think a lot of the problems are bottlenecked by a few different challenges. One of which is evals, right? How do you actually like measure the capabilities of these agents and make sure that the tests and the ways we think about evaluating their performance are actually aligned with real world use cases. Right. There's also the environments problem, right? Like these agents don't necessarily generalize really well. We need to feed them specific environments that, match what the inference or the test time distribution looks like, the way that people actually are going to use them. And, how do you actually like simulate the worlds that these agents live in? And then the last piece is obviously data, right? How do you take those environments? How do you take those evals and then, construct data sets that can be used to maximize, performance gains? And so I think these are some of the, open questions, and, Scale is obviously doing a lot of work in each of those areas. Maybe starting with evals, I'm curious, what are the current ways of evaluating agents? What do you think are some of the big limitations that, existing evals have?
Yeah. So maybe let's start by talking about like some of the really interesting benchmarks that folks tend to pay attention to in the agent space today. I'm thinking of benchmarks like SweetBench, Web Arena, OS World. Today, a lot of these agents or a lot of these benchmarks are focused on like evaluating specific, what we tend to call horizontal capabilities, right? So let's take SweetBench as an example, right? SweetBench basically evaluates how good a coding agent is at resolving GitHub issues from public GitHub repositories. And it measures the success of that agent's attempt by basically running unit tests on the result. If the unit tests pass, then the agent succeeds. If it doesn't, it doesn't. Similarly, benchmarks like Web Arena or OS World, these are again, narrowly focused on the capability of browser agents in the former, and computer using agents in the latter. So for example, like OS World has tasks that are like you give an agent effectively a virtual machine, like a desktop that's loaded with applications. It might have like an Excel sheet that's opened up. And then you basically ask the agent, like, hey, I want you to do something in this spreadsheet, like make some analysis or do some formulas, something like that. And so, these evals historically have been fairly narrow in terms of what they're measuring, and like not only narrow in terms of the kind of capability, right? Like, can the agent work in a code base? Can the agent navigate websites? Can the agent do tasks on a desktop? But also in terms of the complexity of tasks. So really across all three of those benchmarks that I just mentioned, the task complexity themselves tends to be fairly limited in terms of like, number of steps taken to actually complete a task. You're talking, typically less than 20, definitely less than 50. So this is what we would consider to be on the short end of task complexity. Yeah, and I think the trend that we've seen and something that Scale's really invested in is having benchmarks that measure more comprehensive capability, like an agent's ability to do end-to-end tasks. And one great example of this that's out there today is the Agent Company. So this is a benchmark that effectively recreates like a mini environment that a small business or a startup would have. So it basically includes like a chat environment, an email environment, I think maybe a CRM, and it's essentially this logically cohesive environment, and then it includes end-to-end tasks that the agent has to execute within that environment. And so this is really the direction of travel for benchmarks in the agent space. I think as the baseline capabilities improve, and as those benchmarks saturate, the interest is shifting from measuring specific capabilities and measuring like end-to-end task completion, because that's ultimately what translates to economic value for whomever is actually buying these agents.
Yeah, just to add on what Brad mentioned, in terms of complexity, in terms of end-to-end, another dimension that's received a lot of interest these days is about the real-world usage, right? So take Sweetbench, for example, right? So it is still the benchmark to measure progress in software engineering agents. But people start to see that the real-world use of these coding agents, like in Cursor, in Cloud Code, in these different IDs, has been kind of drifting away to from how the Sweet agent data was defined, right? So there's not always a well-defined repositories, a task, and corresponding unit tests for you to test, right? So a lot of these real-world use cases are a lot more open-ended. It started from a user asking just a question, hey, tell me more about this code base, and start to drill down there, right? So multiple interactions and the task can diverge, significantly along the path, right? So, so how to design an eval that can better capture these real-world use cases, especially these monitoring interactions, multi-system interactions. This is also an area of research that we are actively kind of investing in the Scale research team.
Yeah, and on the point of Sweetbench, Sweetbench is a great example of like a benchmark that really set the standard, but also misses the mark in terms of like what the perception of what it evaluates is, right? Like, you'll see all the time, people will say, Cloud Opus 4.1 is at, 78% or whatever it is on Sweetbench. Like, developers are cooked, right? Like, we're toast. And the reality is that that's not the case, right? Like, obviously, things are advancing, but what Sweetbench measures is pretty narrow, right? And so that actually, I think, reinforces the need to have benchmarks that actually capture the full complexity of real world uses, because that actually changes how we talk about agent performance and like, where really we are on that automation curve of like really complex knowledge work tasks.
Exactly. And I think Sweetbench is a great example here, right? Because I think, for anyone who has experience with, production level software engineering, there's so much nuance that goes into like what you're doing on a day-to-day basis. I think I, read somewhere that, right now, a lot of the training data, a lot of the eval sets are like 80% related to code generation, maybe 20% around coding Q&A, but like, most of the time that a software engineer spends is not necessarily like writing code. It's, collecting information. It's identifying, where the issue exists within the code base, getting more details and information on, how the code base is structured. And a lot of that just isn't mirrored in today's benchmarks and evals. And so, when you take something like SweBench, it's not just like the types of prompts and the types of questions that they're asking you that, has a lot of room for, I think, improvements and new approaches to kind of rethinking how to evaluate these models. But it's also how you, verify the solutions and what good actually means. So, for a SweBench, it's all based on unit tests, right? It's, does a code patch, run, can it run and can it pass a set of unit tests that we believe are representative of, what a good solution would entail. Right. But the reality of software engineering is that there's so many other aspects to consider, right? Like, is the solution architecture good, right? Is it something that, your tech lead would want to merge into the production code base? Is it stylistically good? Is the algorithm efficient? And these are things that we just don't capture with today's evals. And I think it's very exciting that, our teams here at Scale are really thinking about how to, measure some of those capabilities, because it's going to result in better performance on like end-to-end coding tasks. And then maybe we can worry about whether or not engineers are going to exist. But, but I think, we have a lot of room to go before.
I think Chetan touched on a really important point where, eval is a significant challenge these days for even this coding agent. Yeah. People feel that for coding, you can obviously write a unit test, provide a verification reward. But in many of the real world cases, number one, not always the time unit tests exist. Number two, as Chetan mentioned, unit tests don't always capture, what it's a good code base look like, right? So that's why in Scale research team, we have a lot of effort into understanding kind of how to define the reward and evaluation that is not directly verifiable. Right, so not something that can be explicitly expressed in kind of a unit test, provided yes or no, but more of a descriptive type of evaluation. Right, so this is a very active research area. I think not only for Scale, but also for the entire research community. Another aspect is that in terms of code type of evals, so it's not always that we have one single step that we can gauge the quality of the agents, right? So a lot of the case, for example, web UI agent, right? It may requires, a click here and there, fill in this field and submit and see what comes next, right? So how to evaluate such of kind of dynamic system in a more interactive way. So for example, a lot of discussion these days around using a web agent to evaluate a UI agent, right? Yeah. So some of these, exciting areas that is also part of our investigation from our research team here.
Yeah. Agents evaluating agents. That's either really cool or really scary.
So I think, we're also starting to see this new category of data products emerging that are pretty essential to, training this next wave of agents. I think, post early 2020, we were aggressively trying to scale up, data sets for pre-training or, human data for supervised fine-tuning. And now all of a sudden we're rapidly scaling up these things that we call RL environments. And these are, really critical for labs to be able to, train new agent capabilities across a variety of domains. Brad, do you mind describing, what these environments actually are and what they look like? Like, what are we actually shipping to, our customers?
Yeah. So that's a great call out. So before I get into that, like a bit about like why we even care about environments, right? It turns out that as of late, like the most effective approach to improving foundation models capabilities as agents is reinforcement learning. And so far, it's really been a continuation of the post-training methods for reasoning, where you basically have tasks and a way of verifying the success or failure of a task, and so on and so forth. And so with agents, by definition, as we talked about earlier, right, an agent is a model that's interacting with some external system. And so if you want to do reinforcement learning to train models to be better agents, then you need an environment for that agent, for that model to interact with during reinforcement learning. And so practically what that means is that environments really are the new bottleneck for progress in RL for agents. And if you think about like what actually is an environment, what kind of environments do you need? Well, really, it's whatever you want your agent to be able to do, right? So if you want your agent to be able to effectively interact with a database or interact with, say, like a productivity software like Google Docs, or write code and do like basic data analysis in a remote code environment, you need to make these systems available to the model during training time when you're doing RL. And so what we focus on a lot here is like, how do we build the most capable and effective environments for our customers to do RL? And there's really two components to an effective environment. The first is the software component, right? So again, take like any system that you want an agent to be capable at using. Let's say Gmail as an example, right? Well, you actually well, people might differ on this, but you can't practically train on Gmail, right? For very valid reasons, right? It's likely against their terms of service. You'll get rate limited. I mean, typically during RL, you're doing like thousands of queries per second for any service that you're interacting with as you're doing multiple rollouts in parallel. And so part of making a good environment is that you need to make basically representative pieces of software that are like, an email server, but one that you can use in an RL training loop. And so there are a lot of technical details that go into, what does this software component need to do to be useful in RL. But that's a big part of it. So you need to build the software. And the second is that you need to make it realistic, right? So, let's say you have this synthetic email server service, right? Well, now you actually need to put emails in it. And it turns out that this part is very non-trivial because, synthetic data can be useful at some things, but it's not really that great at building like entire threads of emails or like, seeding an entire company's worth of sales data in a CRM service, right? And so part of what we do as well is like we figure out, okay, how do we get the best, most realistic data that accurately represents like a specific real world scenario that you would deploy an agent into, and then we put that into the software environments that we build, and then we ship that to customers. And so once you have that, then you're really in a good position to make data, right, that actually uses these environments. So Chetan, I'm curious, maybe you could tell us a bit about like what kind of data can we actually create using these environments?
Absolutely. Yeah. So I think, to your point, I think there's, one more term that I've heard, being tossed around, which is digital twin, right? I think these environments are, really meant to be like very similar clones to the actual, pieces of software, the actual websites, the API servers that these models and these agents are, being trained on. I think on the data side, you brought up a really good point, which is that, to actually make these environments look realistic, it's not just about the software and, can you code up a clone of Gmail? It's, can you make the information that we're putting in these servers look realistic to models and capture like real world distribution? And so, when it comes to how we try to improve our own product quality and make this more effective for our customers, we do a lot of work where we try to source real world artifacts, which means going to businesses that perhaps are no longer operating, finding sources of data that mimic things that have actually been used in a real world enterprise or production setting. And we think that this makes all the more difference when it comes to, the quality of the information that models are looking at. It's real. It captures, the kinds of like workflows and the situations and scenarios that arise naturally in a real world environment. And there's no way to actually, beat that. I think synthetic data can be, pretty efficiently generated, but you're going to find all sorts of mistakes. They're going to make logical errors around, how to price certain products or, what, scenarios might come up. And it's actually very hard to like, capture that kind of distribution. So we think a lot about this for, websites, for clones of products like Gmail. We also think about this for code bases, right? Like how do you capture repositories that have been used for commercial purposes in real production settings and aren't necessarily the set of repos that people can find on the open source internet and models have probably seen ever since we kicked off these really large pre-training runs a couple of years ago. And so finding really good data to populate these environments solves a lot of contamination issues. It makes these benchmarks a lot more reliable. I think when you take out the noise and data that models have already seen, and it just leads to better training gains.
Absolutely, yeah. So besides the artifact, another important aspect about the environment design is about the reward signals that it can produce, right? So Brad talked about this. Many of these, the environment has been mostly used for RL training these days, and for RL to work, it will need to optimize towards a final reward, right? So with the agent trajectory become more multi-turns that can interact with multiple systems that can take hours or even days to complete. If the final trajectory only gets of one final kind of binary reward signal, this is just too sparse for the model to be able to learn more effectively, right? So a big part of the agent, a big part of the environment design is that how we can make sure that we have a very comprehensive loggings about all the interactions of the agents with the system step by step, and so that we can come up with a design kind of intermediate reward that can be used to provide kind of continued supervision to the agent, right? So that is also a key part of of our environment design in terms of really think about in real world setting, right? So what are the reward signals that are most valuable for agent to continue to iterate by itself?
Yeah, no, Bing, I think that's a really important point, and I think is the direction of travel for RL data in particular, right? It's like how do we give process reward signals? Like how do we give partial credit to an agent that maybe didn't even complete the task, but like did things that were moving it closer towards finishing the task along the way. And so there's a lot that goes into like, how do you design those, like you said, logs or even things like process rubrics effectively to do that and really make the agent training cycle more efficient. And so on that note, I think like it's helpful to just kind of like outline like specifically like what is the ingredient for RL data for agents. And so we talked a lot about the environment. Again, like this is just your complete representation of the system that you want the agent to interact with. And then once you have that, right, then basically you just need to make tasks that you want the agent to complete in that environment. And so these are difficult problems that you want the agent to do. And you design them such that the agent needs to interact with different systems, needs to use different tools. And so once you have the environments, once you have the tasks, then of course the third component goes back to the verifiers, right? And how do you tell whether the agent was successful or not? And there are different ways to do that, right? There are like programmatic checks where you can basically like, look at the logs generated by an environment and say like, hey, was this specific action, did it occur in this most recent session? Or there's non-deterministic approaches like rubrics where you use an LLM or, even eventually an agent as a judge. And you have the model basically evaluate whether, the agent met certain key criteria or not. And so altogether, like this is the package that customers need to improve their models. And so we focus a lot on like making the best versions of this kind of data for our customers.
Yeah, absolutely. And I think, like the end goal here is really to help our customers like figure out how to set up these verifiers in a way, right, such that they can give rewards to models. And, part of what we do from the product perspective is, being flexible and giving them, as many verifiers as we can so they can decide if they want to take more of a process-based approach, if they want to evaluate a more deterministic end output, or if they want to, come up with more, qualitative rubrics. And so we kind of package all of that in within the environment so that it's a very flexible product offering. But on the research side, I know that, we do a lot of work to be more opinionated on what we think is ultimately going to drive a lot of the performance gains. And I don't know if there's a clear answer yet for what is and what isn't working. But I think, at least right now, it's kind of important to like think about, this holistic package that includes, as you said, Brad, like the prompts,
Right.
the environments, the artifact data, and then like a very wide set of verifiers that can be used in all sorts of different ways.
What do you guys think about SFT? Is SFT dead? Bing?
I think these days we are definitely seeing more computer shift towards RL.
Yeah.
SFT still play a big role in terms of bootstrapping the system very quickly, right? So a small set of really high quality trajectory can really bootstrap the system and enable the agent to be able to do effective rollout and the self iteration. So I won't say SFT gonna move away, but just that the trend that we're seeing here is that letting the model to kind of learn on its own trajectory. That turns out to be the really efficient way for the model to continue to evolve.
Right. So a little bit of SFT to bootstrap, an environment to allow the agent to learn from, and some hard tasks to learn within that environment. It sounds like that's basically all you need, right? It's just that simple.
That's all you need. Yeah, I mean, RL is all you need. I think thanks to the DeepSeek R1 paper, and obviously, there's a resurgence of RL. But I think the way I think about it is like, with SFT data, the model will only ever get as good as the examples provided, and so you're kind of bound by human knowledge. Whereas with RL, models learn on their own. They develop these emergent properties. They figure out how to solve problems in their own ways, where the ultimate verifiers and the evaluators are being used to teach the model what is right and what is wrong. And so when we think about super intelligence, when we think about how to develop net new scientific discoveries, right? I think a lot of that is going to come from RL, and so that's why I think we're seeing a big shift there.
Yeah. Ultimately, it's about designing the right reward model and enable the agent to iterate and explore by itself and optimize towards that.
Exactly.
I think that is a recipe that really works today, and a lot of the investments are going into this field, apparently.
Yeah. Cool. Well, guys, I mean, it seems like we've covered a lot of ground here, right? So we talked about evals for agents. We talked about RL environments as being the next bottleneck, and we talked about the importance of having the right kind of data to actually do RL in those environments. So like with all these different ingredients in place, Scale's actively working with all sorts of customers and labs, and we're enabling them to really advance the capabilities of their foundation models. So like with this in mind, where do you guys see the agent market evolving, like really over the next 6 to 12 months?
What do you see in the product side?
Yeah. So, I think there are like two main phases that I believe we're going to see in that time frame. The first phase is the one we're still in, where I think a lot of the labs are still trying to figure out these foundational agent capabilities, that are going to help these agents take on more complex work across different domains. And so the way we think about a lot of these foundational capabilities are, they revolve around coding and software engineering. So, agents can, actually learn how to write code, how to use an editor, how to break down larger problems into things that can be solved via code. Another area is around GUI use, which involves like browser and computer use agents, where these agents can actually learn how to use different software, how to interact and visually process different interfaces. And this is a very core capability. And then the last, I think, foundational area is around tool use and MCP, which is teaching these agents how to access data and information and take actions in different systems in a more structured protocol-based format. And I think right now we're just kind of at the tip of the iceberg when it comes to teaching agents how to do these tasks exceptionally well. I think we talked a lot about some of the gaps on the eval side, a lot of open needs around environments and training data that can help advance these capabilities. But I think what we're going to see if things go well is that a lot of these model capabilities around these areas are going to improve quite drastically and rapidly over the next couple of months. And once we get to that point, I think phase 2 is going to be a lot of verticalization and specialization of agents, such that they can complete more end-to-end tasks that are domain specific. And so the kind of environments that you create are going to move from a general purpose operating system to potentially the specific pieces of software that you expect an agent that is optimized around accounting, for example, or legal work to take on. And that's where I think a lot of the labs are going to specialize, pick out their own swimming lanes and figure out what kind of agent and application use cases they want to go after. And we're already, seeing the rise of the application layer right now, and I think this is just going to be a lot more reliable. I think we're going to see a lot more adoption, and we're going to see more players competing in this market. I think around that 6-month mark. So those are my predictions.
Totally, yeah. So from the agent research side, I'm seeing two areas with significant opportunity. One is that we briefly touched on just now in terms of the reward design for agent for environment, right? So how to go beyond just a simple verifiable reward to those more kind of generic, kind of non-verifiable situations with rubrics, with guidelines, right? So this is very active research area, and we have already seen pretty exciting progress in terms of the RL research using kind of a rubric and guidance. Some of our recent publications was talking about that, and positive about the application of those type of research into agent development, especially about environment design. So that is area one. The second area, I think this is more of an early stage, but I see a good potential about kind of shifting compute gradually from RL to environment compute, right? So we have already seen the paradigm of the compute shifting from pre-training to kind of test time compute, where RL is really taking off, right? So making a really significant progress. So next step, right? So environment is going to become a bottleneck, right? So if we do kind of make enough progress there, right? So a lot of environment today are still kind of a static, human defined, right? So we need to create or even purchase, a real world artifact to make it really work. But in order to take it to the next level, right? So I'm seeing a world where we can shift more compute from RL to the environment itself, where the environments become more dynamic, become more self-evolving, while the agent is interacting with the environment can continue to render itself. This is more toward the world model, right? So shifting more compute to the environment development. So that is a trend that I'm seeing. I think that is the early stage, but a very promising area.
Yeah. I think on my end, what I'm most excited about is really, over the next year, seeing more agents emerge that are really capable at long horizon tasks. And just to be clear, when we say long horizon tasks, we're talking about end-to-end tasks where an agent has to basically interact with multiple different systems to do a task that would take a human maybe multiple hours, if not several days to complete. So, I'll give you an example. So if I want to prepare a presentation, and that presentation needs to be based on some market research as well as some internal analysis that sits within my company's Google Drive. And then maybe also factor in some inputs from my boss that was sent in Slack. Today agents aren't really that good at synthesizing all of this kind of information and doing so in a hands-off asynchronous way where I'm not actively managing the agent at each step along the way. And so really all the things that we've been talking about today are going to be key enablers to really improving agent capabilities for these long horizon tasks. I think the first is, of course, just the environments, right? Today, the kinds of environments that, labs are using to train on, they're smaller in scope. They're more narrow. And so really enabling training on larger, more cohesive multi-system environments is going to be key. The second is just, as Bing was talking about, right? The training infrastructure needs to catch up, right? A lot of the RL infra today came through reasoning and the build out for reasoning. And comparatively speaking, right, the infrastructure compute requirements for reasoning is much more self-contained and doesn't involve this environment management, all this different kind of complexity. And so I know this is something that our customers are actively investing in and working on. And so I think once you have the environments that actually capture the full scope of end-to-end systems and tasks that you want agents to do, and then once you have the infrastructure that actually enables training agents that can use those environments, then I think we'll see advancement really pick up will really catch up. And the last thing I'll say is, again, just going back off of what Bing said, verifiers, right? So it's not just about verifying the outcome, but it's about verifying the process, right? Like understanding, like, hey, what steps along the way did an agent take that actually contributed positively towards achieving the goal? And once you can get these more dense reward signals, that enables a lot more interesting asynchronous training approaches where you actually can train on rollouts that haven't actually completed the task. And so that's going to unlock a lot of efficiency as well. So I think, as these trends converge and improve, I think we're going to see a lot more capable agents by the end of the year or within a year.
Yeah, exciting time.
Very exciting. Yep.
Cool. Well, guys, I think that more or less wraps up our first episode of Chain of Thought. And we got some pretty exciting ones coming up. So I think over the next few episodes, we're going to dive really deep on some of the upcoming benchmarks that we're incredibly excited about. So great. So that wraps it up. If you have any questions, feel free to leave so in the comments, and we will dig into them next time. Thanks.